Hi everyone, welcome back. Today we are going to show you a project called Diabetic Retinopathy Detection using Deep Learning. So this is our final web application. Whatever you see here, it is having so many options and so many information about the diabetic retinopathy. We will be discussing each and everything one by one. First we will see how the result will come, and then in this procedure we will try to understand how we can detect the diabetic retinopathy using our deep learning. So first we will discuss about the existing papers, IEEE papers, and we will make sure what is their existing system is there, and then once we understand their existing systems, we propose our own methodology or our proposed system which will be better than the existing system, and then we are going to discuss about the disease, the basic information about the disease, what is that. So once we have a better understanding about the disease, then we are going to see how can we code, how we are coding, what are the methodologies, what are the technologies, what are the coding models are being built, how much accuracy they are giving, what is the loss we are getting, how we integrated that using in our web application that you are seeing now. All these things will be discussed one by one. Okay, so now initially I just want to show you how it actually works. So like this, you see, once you upload any diabetic retinopathy images, I'm going to get to know what disease. This is having no disease, this is not DR. Okay, this doesn't have any diabetic retinopathy, so it will not be having any sign or any treatment. But you can even download the PDF of that report and you can open it and you can see here. So like these reports can be generated for that patient. So now what we'll do is we'll try to upload one more image and we'll see. So it says moderate, the level of the diabetic retinopathy is moderate. What may be the cause? Progressing diabetic retinopathy with increased damage to retinal blood vessels. What is the treatment? Control blood sugar and blood pressure. Consider laser treatment if necessary in this condition. Same thing you can get it in the report. Do you understand? So now what we'll do is we will try to discuss, and we will be discussing entirely how we coded, what is there in this web application one by one. But before that we will try to understand what is the diabetic retinopathy is, and then we will try to understand already there are some IEEE papers, so what they done, what is their existing system. Once we understand their existing system, we will try to define our methodology. So once we define our methodology, we need to prove our methodology is better than the existing system. So that we will do with help of accuracies and losses. So we'll do these things one by one, and finally I will be letting you know how we coded, what are the codes I used, and all those things will be discussed one by one. Okay, clear? Don't skip the video, please watch until end, and you will be getting so much of information about this. So initially we are trying to discuss about the diabetic retinopathy. What is this? So this is a side effect of the sugar level increase or diabetic patients. Okay, this is one of the symptom I can say, or side effect I can say. So here, due to more sugar level in the blood, so blood pressure will increase, that will damage the blood vessels, okay, in the retina. So that will increase the random growth of the blood vessels in the eyes. So if it is not treated properly, it may impair permanently blindness. And why is it caused? What is the main cause of this? The main thing here is directly it is sugar level. That is diabetes is the most important reason here. So diabetes is nothing but sugar level increase. Sugar level will directly impact on the blood pressure. Blood pressure directly damage the blood vessels of the retina. So that will allow to increase the uncontrollable growth of the blood vessels on the eyes, which covers that eye area. So mainly damage the tiny blood vessels in retina, lead to leakages, swelling closer to these vessels. Okay. In advanced stages, new abnormal vessels grow, which can bleed or scare the retina. I think now you understood what is this and what is the main cause of this. So now how to handle this? So how it happens? Okay, what are the different stages are there? Mild is there, non-proliferatory retinopathy is there, moderate non-proliferatory is there, severe non-proliferatory is there, and finally proliferatory diabetic retinopathy is there. What are they? Okay, how they differentiate is small balloon like swelling in retina blood vessels, we call that as a mild, and in moderate some blood vessels become blocked. Several non-proliferative retinopathy is that more vessels will get blocked and the retina will lack the oxygen. And proliferatory diabetic retinopathy is there. Here, new abnormal blood vessel growth. This is one of the dangerous. Okay, so fragile and prone to bleeding, scar tissue forms leading to the retinal detachment and blindness can be happen because of this. Treatment available for this. What are different treatments are available here? One is medical control. Here under medical control treatment, strict control of blood sugar. So we are trying to control blood sugar itself directly. We don't want to treat to retina. So let us control the blood sugar of the person. So that will control the blood pressure. That will control the retinal problem. So they are all dependent on one another. And laser treatment is the second option. We call that a Preprocessing. So stops or slows the leakage of the bloods and fluids in the retina. Anti-VEGF injections are there like ranibizumab, which is used to reduce the vessel growth and as well as the swelling. And the next one is vitrectomy surgery is there, removal of vitreous gel or blood advanced causes. So here you can say like this treatment is specially used for bleeding cases. And when we discuss of the statistics, the numbers, how many patients are there like that. So worldwide around 537 million people live with this diabetic issue. Around 1 in 3 diabetic has a sign of DR. So you see that number. Nearly 93 million people globally have a diabetic retinopathy, leading to cause of blindness in working age adults. It is starting from 20 to 65. You can check it. Okay, so this is the biggest problem. And when we come to India, so the India has diabetic capital of around 77 million diabetes. Among those diabetes, diabetic retinopathy is 18 to 25% affected. So mainly it is seen in poor controlled area, sorry, urban areas. Okay, in India we are discussing. In urban areas we see this. Most causes diagnosed too late due to lack of screening. So it should be controlled at the lower stage. If it increases to higher stage, what is the problem? Is cost of treatment. You see here in India, early stages 2000 to 10,000 laser checkups, advanced stages 40,000 to 1 lakh. Whereas when you take annually cost estimation around 25,000 to 1 lakh 50,000 yearly in India. If you go to USA, it is $300 to $1,000 per visit. Okay, and when it goes to advanced stage, it will be $2,000 to 8,000 per injection or surgery. And annual cost estimates are around $5,000 to $15,000. So I wanted to make sure you understand why we need to detect this in early stages with much accuracy. So here, where does deep learning come into act? So how deep learning will help? How whatever model we are building, how they can help us? One is automated retinal image analysis. So with the help of deep learning, you can able to analyze the fundus images and we can understand and detect the proper level of the retinopathy. And you may say now doctors already can do this. The problem with the doctors is that any human being, we will be having a human error. So our brain is limited to some numbers. So above that we can't analyze. For example, you can't analyze 1,000 variations. You can analyze 3 to 4 variations. So we will have a limitation. We can understand the things, but we will be having limitation in analysis when it comes to quantity or variations. Whereas deep learning models, they can understand any number of n number of variations if you train them properly. And when it comes to speed, they are much faster and much accurate, and they can do it in lack of images in minutes, like thousands of images very quickly. So you saw that now just we upload image, we'll get a result. Accuracy achieved by like around 85 to 95 compared to human one. More than 95 we can achieve if we train with more data. We are getting better result in our case also, and you can deploy it anywhere in mobiles and systems and servers. You can do it. So some examples of the deep learning models are like ResNet 50, Inception v3, EfficientNet, VGG, or hybrid CNN models, or Google's DeepMind. Now, real life implementation. So Google's ADA project with an Indian hospital, Arvind Eye Hospital, to screen DR automatically. So they are already trying to use like this technology. So this technology is in research as well as in implementation. And Indian startup research groups developing low-cost mobile apps for this purpose. And summary of whatever we discussed till now. So this is about the diabetic retinopathy and the data about the diabetic retinopathy and what is the cause, what is the treatment, and mainly how deep learning will help to overcome or to resolve the part of the problem, and what is the cost of the treatment in India as well as other states. So now we'll come to the stage where we need technical information for our project. So that is the references and their existing systems. What are the papers that we are referring and what are their existing methodologies? So we'll discuss those things one by one. So we already have 3 papers. We have multiple papers actually. We have around 7 to 8 papers, but among them we will be taking top 2 to 3 papers. So then we'll do research. If you ask us, we can send all these papers to you. You can analyze it. You can understand that. So these 3 papers we are referring, and first we will try to read these papers. We'll try to understand technically, accurately. We'll understand, and we'll try to understand what methodologies they are using, what dataset they are using, what accuracy they are getting, all those things one by one. So we gone through these papers and we made a note. Okay, so even if you approach us, our team will be sharing those notes as a synopsis. You can read, you can take these papers, you understand what is there, and we are already discussing about these papers, cross verify them, and then you can approach us if you want complete support in this project building, and we will be helping you. We are not just giving you a code and leaving. So this is service. You can just feel like a teacher. Okay, and we will be helping you with the entire process. Okay, and we will be providing you code, documentation, explanation, implementation from A to Z. We'll be having everything here. So now this paper, what does this contain? The first paper. So if you see here, this is the first paper that we opened there. So the dataset used in that paper is Messidor dataset, which is having around 1200 color retinal fundus images. Among them 540 normal, 153 mild, 247 moderate, and 260 severe case images. And for classification, only 2 classes they are having: normal and abnormal diabetic retinopathy. So image sizes are available here. What are the dataset they use? These 2 datasets they use. So their image sizes and everything is given here. And now what are pre-processing they done? They done grayscale conversion, and then they are trying to use machine learning in this paper. So they need to manually extract the features. So for that they need textural feature extraction. But in our case we will go with the deep learning. We don't need manual extraction. Deep learning's main profit is that you don't need manual extraction. You can just feed the entire image. Each pixel of the image is a feature. You don't need to manually extract any feature there. But here for machine learning, these people are extracting the features like histogram, bandwidth, bin width, threshold, and upper histogram, like that. Upper histogram informations are being taken, and local energy based safe histograms are being taken. Why histogram? Nothing but histogram is a map of a density of the the color of the pixels. So indirectly they are mapping the pixel values as an value of a data, and they are taking it further. And what are the filters they are using? Here Gabor filter they are using, and they are calculating energy and orientation. Why they are doing is they need to do it because they are going with machine learning. They need features from the image, they need manual features. Okay, built histogram over 32 sub regions. Again Gaussian weighting they applied, and finally they are having 512 dimension. So total 512 features they extracted manually. But in our case, if I use a deep learning, if I take a image 256 cross 3, that multiply 256 3, all these numbers, those many features will be having, more features than 512 dimension. And then so these people are using SVM. Okay, so they are using linear polynomial and radial based functions. Okay, then they are using SVM and RBF, which performed better in their cases. So finally they are getting RBF with 90% accuracy and 93.1 AUC curve, but accuracy you should remember. Okay, 90.4% accuracy, that's all. This paper, the first paper. And when we move to our next paper called Diabetic Retinopathy Detection Using Deep Learning, written by Kalam Swati. So now this paper, what does this contain and what are all the models they used and how much accuracy they are getting, we'll see one by one now. So in this paper they used a dataset from Kaggle with high resolution retinal fundus images. Okay, they are having DR present or DR not present. They are going to binary classes, they are not going with multiple classes. Okay, purpose used to train the CNN models. They are using CNN models, their custom CNN models. And what a pre-processing they done, like they are using OpenCV library. The purpose is to remove the noise removal they done, and then resize the image, and they used augmentation. We'll discuss why this augmentation is being used here. They done rotation, cropping, some other augmentation things which are not provided. Okay, and then model used are custom CNN models. They built their own layer by layer custom CNN models, as well as transfer learning VGG16 they use. And then they used all these four models, and then they are comparing, and their presentation says that their custom CNN model getting 94% accuracy. So now this is second paper. So second paper is discussing about training 4 CNN models. They are not much concentrating on the pre-processing, they are concentrating much on the augmentation, but they are getting 94% for their custom CNN models, whereas VGG, DenseNet and SVM is not performing better in this case. Now we will see the third paper, which is Diabetic Retinopathy Using Deep Learning, written by Shivaji Joshi and their team. So this is 2023 international conference paper on the diabetic retinopathy. So now this paper, what does this paper use and what accuracies they are getting and what models they are using, all those things we'll discuss one by one. So this paper is using Kaggle 2015 diabetic retinopathy challenge dataset, which contains around 35,126 images, and fundus images, left and right eyes images are there. And one more dataset is Aptos 2019 blindness detection dataset, which contains 18,590 fundus images. So the classes in this are no DR, mild, moderate, severe and proliferatory. Different dataset the information they are giving, different models they will be using. Pre-processing done, a cropping and scaling, data augmentation they done, okay, label smoothing, noise regulation, and image resolution. They didn't mention exactly which model they used, which approach they used, but they mentioned like they done something. And model used is custom CNN with pre-trained weights. Pre-trained transfer learning models they mean. Okay, ResNext T50 model, EfficientNet B4 and B5 model. So once we take all these models and they are using SHAP for explainable AI, but in our case we are trying to concentrate on using GradCab with a better result. It will give better analysis with the images and their results on highlighting. So for example, what is explainable AI images? I will show one. So like this. So we are going to get GradCam based explainable AI. So that paper uses and termed mean, okay. Best accuracy they are getting around 99% sensitivity and specificity they are getting. Okay, these are the three different models they are using, and one thing they are not mentioning very clearly is that which particular model is giving 99%. It is not much clear in this paper. When we gone through a paper, they are saying we are getting 99, but which model? Because they are calling multiple models here: efficient B not, ACR, REST next 50. Which one is giving? Whether it is efficient B4, B5, or which model is giving that much accuracy? Whether all the models are giving 99? Not possible. So not much clear about the result. Okay, anyway, so this paper is discussing all these things. Now let us propose our own methodology which is better than the existing. So now what I will do is I will tell you what we can do, what extra we will be doing. So under pre-processing, these papers are not concentrating much. If they are concentrating, they are using only noise removal functions, but removing just a noise is not an important thing here. You need to know, you need to have a better vision, you need to make sure your data is much easier for our models to understand, and that will be leading to better accuracy. You can't use one filter and leave it. So for that we will have a sequence of processing. First we do grayscaling, then we do apply enhancement technique. Okay, so this is very special enhancement technique. I won't give a name here. Okay, and after enhancement, okay, let me tell you. So I am using CLAHE. Okay, you can take this. So CLAHE is one of the good enhancement technique, okay, which will make our images look better. And then we apply noise removal functions. Here we will apply, once we enhance, we apply multiple noise removal functions, and then after the noise removal functions we will apply edge detector. No paper is speaking about this edge detector. As we already know, diabetic retinopathy is mainly based on the blood vessels, okay, spread like this. Using edge detection, we can highlight these blood vessels, we can segment these blood vessels, we can make sure these blood vessels are being highlighted, so that will help our models to learn better. So that's what we are doing here. So after that we will highlight the edges with red color, so the results will look like this. Few images I will show. Can you see? So we are trying to highlight the blood vessels. Okay, and then after applying those many pre-processing techniques, what we are doing, actually there is another problem in our datasets. So the dataset number of images are not same. So diabetic retinopathy may be 1000, so this will be having 200. So another class moderate will be having around 600, so which we call them as an imbalanced dataset. So the problem with imbalanced dataset is it will lead to uh, or overfitting or underfitting issue. So what does that mean is, for example, let us take, there is a box so which contains around 1000 apples, and 10 tomato. If you take a boy, 5-year-old boy, and you train him with both of them, okay, in the end he will forget even you trained him about tomato or some other fruit. He will remember only the 1000 data, because this data was so used. He will be learning better about this and he will forget about the remaining. So this will happen. This will call overtraining. Okay, overfit or underfit issues. So to resolve this, all the papers are discussing about augmentation some or other way. So that is the main purpose. We need to balance them. What they will be doing is, for example, here there is a diabetic retinopathy. So now I can create 10 more from this. What I will do is I will rotate 5-degree right, and then I will increase the intensity by 0.001. Okay, I will zoom it to 0.0026. I will create a new image. Maybe it looks like this. Okay, so like this. So rotated. Okay, it is rotated in this manner, and the new image is created like this. We'll try to balance them equally. In our case, we balanced it to around 1000 images for each class. Previously they were not 1000, but now all of them are 1000. So we call this as an augmentation. We are applying augmentation. We are applying our own pre-processing approaches, letting the region of interest. We call them as a region of interest, that is blood vessel. And then what we do is we are going to build models. So in our case, we are trying to go with the EfficientNet model, MobileNet model, and hybrid of EfficientNet as well as MobileNet models. We can try like this multiple combination of the models. And what we are getting for this, what accuracies we are getting, you can see here. I'll show you some accuracies. I have trained only for 50 epoch. We need to train more than this. Our training accuracy is 99.58 and our testing accuracy is 97.40, which is far better than the previous papers. So this is a confusion matrix and this is our complete classification report. If we increase our number of images to around 5000 or 5000 each, we will be having a better result. So that will take training time little bit more, but we can expect good result in that case. 5000 for each will be 25,000 total number of images. If you have a stronger GPU, you can train it to 200 epochs, 300 epochs. It will take hours together, 4 hours, 5 hours, 6 hours, 8 hours for training. It depends on the system's capability. So once we train all these things, and then what we do is we gonna save the models like these h5 files. So now using this h5 files, we will integrate it in our web application. So you can see here that h5 file is used here. So we'll try to integrate this saved model into our web application. We coded this with help of Flask. For the front end, I am using HTML pages. Okay, for the back end I am using Flask, that is app, and static and CSS, JavaScript, whatever the coding things are there, those things are being used for the front end look. HTML, CSS, JavaScript goes for the front end, Flask will go for the back end. So how this Flask code looks like, I will show you. So you can see here, this is our Flask code, backend code, where we have login, register, and feeding that login data to the MySQL database. We are saving that into MySQL databases, all the informations. So now we'll see how our code is working. So this is our app.py, where when you enter the data, for example, we'll come here and our home page will be this. So we have login as well as register page. So here when you go to register, you can register with the user ID and password. Let us take diabetic retinopathy 123. So this information will be saved to our database DB123. In our MySQL database it will be there, because I am using XAMPP for that. Okay, MySQL I started, I connected MySQL database. So it is a real-time working database. Okay, you can check with the admin and there is a table. you can visit our websites for few more projects. You can check all these things. Okay, there are more number of type of project. You can see artificial intelligence, machine learning, data science, computer vision, NLP, web development, IoT, image processing, image processing with MATLAB, embedded system. You can see so many types of project we handle, but among them we concentrate mainly on ML, AI, data science, computer vision, and NLP. So if you have any project in your mind, if you have any ideas that you want to implement, you can always approach us. We'll be helping you with implementation of that code. So this is our database. Okay, so this database here, that data will be coming and saving. So whatever the login information we do there, so all the information will come, will save there. So now what we'll do is you can log in. So once you log in, this page will open. In our case, this page is actually index.html. This is the home page. So now in the home page, when you click on the function called here upload clear image, okay, upload image, so you will be taken. So here when you click here, you will be taken to the next page where you can choose the file and upload. So the next page name is actually this, where it will ask you to upload clear image, upload retina image, JPG or PNG, whatever image you have, you can upload it. Okay, we accept all the format of images. So once you upload all the format, any format of images, we'll take that and we'll feed to our model. So that we are doing here. So these are login and registered database communications. Okay, so login, we have function, okay, where we take the data you enter, we'll connect with the database and we validate. Okay, if you are authenticated, then only will allow to index.html, that is home page. If you are not authenticated, this is a register page. Okay, we'll try to stop. Okay, we'll try to give this Gmail is already in use. If you are using same Gmail, or if you are using wrong data, we'll say please use proper data. Now, so that image uploaded will come to our model. Okay, here, so our model will predict with this database as a backend, and it will try to say which disease is that. According to that, this is what precaution should be generated. And then, so see here, new image I am uploading. So it is mild. So you see here, blood vessels are highlighted very clearly here. Why these things are highlighted to this much level? Because we use such a pre-processing techniques in middle. We are making sure our model learns better and easily. So we are making some highlightation, as you do highlighting with some yellow color in your books to understand it very easily. Okay, with less time. So the same manner, when you identify and when you try to highlight the region of interest, ROI, in a deep learning, always it will lead to better result. So he can even download the PDF. Okay, so as you already saw, so that download PDF function is here. So whatever the report is that we can make sure it can be downloaded. I think now you understood the entire project. So if you need the complete code and our support, please contact to the number given below, and our team will be responding and will be helping you with code, documentation and implementation of these projects. Thank you very much. Don't forget to like, subscribe and share this link to the people who are in need. We'll see you in the next video.